Hi there. I am Paulo Braga, Food Technical Manager at Foodology by Univar Solutions, and I've been supporting enzyme applications, including olive oil, since 1998 in Europe, North America, and Latin America. We are delighted to share with you our experience with enzymes in the industrial process of extra virgin olive oil extraction from outside European Union market. Harvesting and milling represent a small window in which solutions to industrial problems must be found quickly so as not to compromise the desired industrial results. In the current context of high value of olive oil, producers are looking for higher yields without compromising quality and more sustainable processes, such as generating lower oil losses due to waste in pomace, lower energy and water consumption, more fluid operations and cycles, less frequent maintenance. It is about all of these that we are going to talk today in our webinar, The Benefits of Using Enzymes for the Extraction of Olive Oil. To this end, I'm delighted to have Pablo Canamatas with us. Pablo is a scientist and agriculture technician in the field of olive oil production and quality. He has been involved in the extra virgin olive oil industry for over 28 years. Pablo is an independent consultant for private companies in the United States, China, Japan, New Zealand, Chile, Israel, Mexico, Italy, Argentina, and others. He is frequently invited as a judge at international competitions around the world. I also want to thank Novozymes, the world leader in enzymes, for partnering with us to make today's session possible. So thanks for joining, and please give us your questions after the presentation. And by now, Pablo, go ahead. Adelante.
¿Arranco, Paulo?
Sí, por favor.
Well, thank you, Paulo, very much for the presentation. Good morning, everyone. I was invited today to talk about my experience in the use of enzymes by the people from Univar. As you well know by now, enzymes are heavily used outside Europe. So we've been working with them for many years, and I was invited today to sort of share a little bit that experience. So I guess before we move on to results or impact on yields and stuff like that, we'll probably have to define or sort of determine what enzymes are and how they work on olive paste. A very important aspect to understand, which I believe is key to understand why enzymes are heavily used and are approved for use in other countries, is that they're simply biologically active protein substances that help degrading pectins and cellulose in the cell walls and vacuoles where the oil is located inside the pulp of a fruit. One very key aspect that I believe is extremely important to understand is they are very specific to the substrate that they are meant to be degrading. So they only degrade pectins and cellulose. In the case of these pectinase enzymes that we use, they cannot degrade any other compounds in the cell walls of a fruit. Another very important aspect is that they work as proteinates. They are not additives. The legislation for olive oil making does not allow the use of additives in this case. Pectinase enzymes are proteinates simply because they enter the process, modify the paste condition, and then they exit the process before the final product is made. Another very important aspect in this case to understand is that they are exactly the same enzymes that exist in the vegetal tissues inside the pulp of a fruit. So we are not adding externally anything that is that doesn't exist already inside those vegetal tissues. Obviously, those enzymes that are inside the pulp of a fruit that belong to the pulp of a fruit that are inside, they're naturally inside. That enzyme system, which we call endogenous enzyme system, really depends on the season or the activity, how active those enzymes, internal enzymes are. Depend on the season, on the cultivar, and the fruit maturity as well. Obviously, as the fruit, we will see that as the fruit ripens, that endogenous enzyme system will become more active. But the truth is, when the fruit is green, low maturity, those enzymes are heavily inactivated by the presence of polyphenols, and as a consequence, we are required to add enzymes externally. They're soluble in water and they're very easily eliminated by centrifugation, so there's no way they can actually find enzymes in olive oil, in the final product. And obviously, and I think the key message here is they are essential for processing fruit of low maturity. And we'll see why that is so important for all those countries outside Europe that make olive oil and have to compete with Europe. Based on the experience of many years working with these products, I say that improvements range from 0.8 to 2%, really depending on the fruit condition. Obviously, as the fruit ripens, the yield improvement decreases naturally, simply because the internal enzymes start activating inside the pulp and do the work we need them to do. But in general words, I would say that if you use enzymes, you'll probably be gaining somewhere in between 8 to 20 kilos of oil per 1,000 kilos of fruit that you process. So why we use enzymes? That's I guess that's the most important aspect to discuss today. Obviously, enzymes are a very important tool for these new companies producing olive oil outside Europe that are forced to compete with the volumes of Europe and are forced to compete in obviously in quality, not on volumes. So as a consequence of that, these new companies in this new world try to start processing fruit early in order to process fruit of low maturity, because that gives way to oils with longer oxidation stability and a longer shelf life. Nowadays, oils are traded based on shelf life, and that's very important. We know that the earlier we pick, the longer the shelf life of the oils, in general terms, of course. There's also a tendency of picking early as well, because green or oils coming from low maturity fruit tend to give way to oils of better sensorial quality as well. Also, the strategy of starting early in order to finish early the harvest has a huge impact on the bud differentiation of flowers for the next flowering year. So obviously, the sooner we remove the fruit from the canopy of the trees, the lower or the lesser the impact, the negative impact of that on the bud differentiation of the next flowering stage. So it's very important for these companies to start early, to finish early, in order to avoid that negative impact on the flower differentiation, so as to have more consistent crops along the years. And the other reason, obviously, for starting early the season is that you're facing frost issues, frost events, fungal diseases that appear on the growth, and obviously picking fruit early means that you'll definitely be avoiding late frost and the negative impact of those fungal diseases I was talking about. So when we use enzymes, we clearly guide ourselves based on the fruit maturity, or what we call the maturity index, which is an index that we calculate based on the color of the pulp and the color of the skin of the fruit, in order to determine whether we are going to use enzymes or not. Typically, enzymes are used anywhere in the process where maturity index is anywhere below 3.54, because we know that within 3.54 maturity or below, we are going to have a cost-effective impact of the use of enzymes for oil release. Things become a little bit more tricky, I would say, when a maturity index goes about 4. You may have some good results, but you may need to test whether the enzymes are really having an impact after that, because as we know, after maturity 4 or 5, the enzymes that are naturally present in the fruit will start doing the job that of releasing the oil that we need to get done. But what happens when the fruit ripens? Obviously, what I mentioned before is just a maturity index. It's an index based on the visual assessment of the fruit. But when the fruit ripens naturally inside the fruit, there are a few processes that are going. One very important one is that as the fruit goes from green to black, the texture of a fruit starts dropping. As we know, fruit that is of low maturity is hard, has a very firm texture. And as the fruit ripens, the fruit becomes softer. That's because the total pectin content of the cell walls in the fruit starts dropping at the same time. So what determines that firmness of the texture of the pulp of a fruit is the total pectin content. So the more pectins we have in the cell walls, the firmer is the pulp of a fruit. And as the fruit ripens, because those enzymes inside the fruit start becoming more active, because polyphenols disappear, then they start degrading pectins, and as they degrade pectins, the texture starts dropping and the fruit becomes softer. That's what happens in a natural ripening process. So that pectin degradation is extremely important in that physiological process. And those enzymes, what they do is just simply degrade all those pectins and cellulose and hemicellulose that are present in the cell walls, in the middle lamella, which is that glue that keeps all those cells together. So there's an important impact of degradation of those pectins in that area, and by degrading those pectins, the oils become free. It gets released from the inside, which is what we need before going into centrifugation in the process. This is a microscopic photo taken by Magfa et al., a group of researchers in Spain. A very good photo. You see here all the cells in the cell wall of the fruit that are kept together by that white like glue that is pectins. That's the middle lamella. And as we put enzymes in there, the enzymes start degrading those pectins, and the cells start becoming free, and as a consequence, the oil that is inside those cells can come out freely. So, in which cases do we use enzymes? Do we use enzymes all the time in the whole process? Well, not really. I mean, there has to be a justification in the condition of a fruit to justify the presence of enzymes in the process. So when do we use enzymes and what dosage? Well, clearly, as I mentioned before, the most important parameter to determine whether or not we use enzymes and how much of them is the fruit maturity. So any time where maturity index is below 3.5, based on my experience, I pretty much guarantee that enzymes will have a cost-effective impact, positive impact on oil release. When we have problems with extraction efficiency at the mill, we know that we are all looking for that famous 85% efficiency of extraction. When we are below that efficiency, we tend to use enzymes in order to help in removing or releasing oil from the paste to improve that key parameter. When we are dealing with difficult paste like Arbequina, Lechino, Picual, Hojiblanca, I have a lot of work done in Arbequina, which is a very popular variety outside Europe, on the use of enzymes. And clearly, certain varieties where are not easy to remove the oil from the paste, enzymes do help in getting that done. Also, in cases where we have, regardless of the cultivar that we're dealing with, in cases where we have a problem with high viscosity of a paste due to low maturity index of a fruit, or low fruit moisture content, or low oil content in the fruit, or fruit that is simply way too small with a very small flesh to pit ratio, in those cases, enzymes do help in making the paste less viscous, in reducing viscosity, and getting the oil to be released more easily. Also, when we have only large crusher grid sizes in the processing plant, when we only deal with 6 or 7 mil grid sizes for the crusher, and we don't have a small grid to use with low maturity fruit. We know that we are not cutting the fruit small enough. Then we know that we have enzymes to at least release the oil biologically. As a very general rule, I'd say that if we are dealing with fruit that has low than 2.5 maturity, we'll probably try to start with a dosage of 450 mils per ton. Or if the maturity index of a fruit is higher than 2.5 and below 4, I will probably start with 300 mils per ton, and then I will certainly adjust that dosage depending on the oil losses in pomace and on the paste viscosity that we're getting. And another aspect that needs to be considered that is very important is deciding on the enzymes mix, which is a key factor in processing, because we know in the market there are enzymes that are soft, enzymes that are stronger, and we need to make a good mix of those enzymes in order to target the kind of fruit condition we are dealing with at the processing plant. This is a work I've done many years ago. I'm trying to understand how different enzymes worked on fruit of different maturity index. And what you're going to get to see here is the yield improvement against a control without enzymes at different maturity indexes. So 0, I mean, fruit that is really green, 1, 2, 3, 4, 5, etc. Like moving forward in terms of maturity. And as you can see, these 3 different products had a clearly different impact on the maturity, on the yields obtained from the paste. Clearly, viscosime L in this case, which is the line in yellow, is clearly a very strong enzyme that acts really, really well and makes a difference when the fruit maturity is below 2, as compared as other softer products that tend to become as important when the fruit maturity is over 2.5. But this is just to show really that different products in the market will have a different way to work on the paste based on how green the fruit is and how viscous that paste is in the process. So how enzymes came about for us working outside Europe? Well, if you pretty much see how the olive production developed outside Europe, I say that in the early 90s, new plantations started being developed in new countries like Argentina, Chile, Australia, California, New Zealand. And it was quickly obvious that it was not possible to compete with Europe in terms of volumes, and we had to work and compete with them in terms of quality. So the strategy, the production strategy of these companies was obviously focused on trying to get the best possible quality without compromising yields. So as a consequence of that, it was obvious that all of us, we had to start processing fruit early in the season to get better quality oils. But in terms of enzymes, there was a general lack of knowledge. There was no specific enzyme products for making olive oil. The enzymes I remember that we were getting back then were enzymes that were used in the wine industry. Still, they had an impact on yield improvements. We were recovering around 0.8 to 1% more oil, which is somewhere around 8 to 10 kilos of oil more per 1,000 kilos of fruit processed back then. And in the early 2000s, the new food commercial standards of those new countries like Australia, California, Argentina started being developed. And as they were being developed and put together, there was a need for understanding what new processing aids could be used for olive oil making, so they could be adopted for those new standards. And as a consequence of that, we all started working in the characterization of both fruit and enzymes present in the market to understand how to maximize the use of these tools in those years. By the 2010 to 2020, there was an adoption of the enzymes in food standards of those countries. Also, there were better informed suppliers offering more specific products for olive oil making in those years. So new enzyme products were now basically more effective in removing oil from paste, and there was a fair bit of research done in enzymes outside Europe, and extension of the results obtained in those researches that gave way to a massive adoption of the enzymes in the extra virgin olive oil industry outside Europe by the 2020s. And then new studies show that there was an energy savings and lower environmental footprint by the use of enzymes, and because we were using now more specific products developed for olive oil making, yield improvements now were much more significant than 20 years before, getting somewhere around in between 1% to 1.6%, or which is the same to say as 10 to 16 kilos of oil more per ton of fruit. Obviously, this depending on the fruit condition. So how do we evaluate enzymes performance? I mean, we adopt enzymes for olive oil processing. How do we really understand whether they are really doing the job they are meant to be doing? So in order to understand their performance, we certainly need to go through a few tests to sort of convince ourselves, well, okay, this is the way to go with these tools. We obviously look at cost effectiveness. Enzymes are expensive tools, but they are extremely cost effective, and they have to be cost effective to justify their use in the process. We evaluate industrial efficiency, which is the most important parameter in industrial parameter in olive oil making. We look at the yields as well. We look at the energy consumption of the malaxers and paste pump motors. We look at the impact of the fluidity of the paste that has on the paste pump speed. We look at the cleanliness of the oil, the paste viscosity, as I mentioned before, a very important parameter. We look at the oil release from paste, the visual oil release, which is a very important also aspect that we have to assess during the process. We look at the pomace condition. We evaluate the sustainability of the use of these tools, and whether or not there is an impact on oil quality. In terms of cost effectiveness, I guess if we are going to be using enzymes, we certainly need to prove that they are making us make money, basically. This is a typical example of an enzymes test to understand what the best dosage is and whether that dosage is cost effective or not. This is a test done on a controlled paste, paste without enzymes. 200 mils per ton, 300 mils per ton, 400 mils per ton, work done in Arbequina, understanding well what the oil content of the fruit is, what the moisture content of the fruit is, all the processing parameters, obviously measuring how many kilos we obtain in each case, so we can actually work out the efficiencies of the process, and then we can sort of taking into consideration the price of olive oil and the price of enzymes, we can sort of carry out a cost-effective exercise to know whether these tools are giving us a net benefit per ton. In this case, clearly the 400 mils per ton dosage gave the best net benefit per ton, so $56 per ton net of benefit against the control without enzymes. But this is obviously the kind of exercise we have to look at when we use enzymes in the process to understand whether or not enzymes are being cost effective and which dosage is the most cost effective in the process. If we are able to measure oil content in fruit, like in this case, in this trials done in San Juan in Argentina a few years back, then we are able to measure industrial efficiency. If we know how many kilos of fruit we have processed, we know the kilos of oil that we obtain in each case, then we can work out the yield, which yield are kilos of oil by kilos of fruit processed, and then we can work out the industrial efficiency. I mean, what the percentage of the oil that we were able to recover from the total oil that we had or we received with the fruit in the mill. So this is a very important way of understanding whether enzymes are working or not. This is, again, another trial done without enzymes, which is a trial 1, trial 2, and trial 3 done with the same enzymes at different dosage, using talc powder in this case, which is another very important processing coadjuvant. And in this case, the trial 3 gave the highest industrial efficiency as compared to the control, which obviously gave us an indication of what kind of setting and dosage, enzyme dosage had to be used for this particular fruit condition. When we don't have the ability of measuring oil content in fruit, so we don't know really how much oil the fruit has, the fruit that we're going to process really has in it, then the only thing that we can actually measure are yields. So we can actually measure how many kilos of oil we process from how many kilos of fruit we have. Still, measuring oil yields, for those of you that can measure oil losses in fruit, still measuring oil yields is important and give us a very, very good indication on whether enzymes are doing the job or not. I would probably say that a yield increase of 0.3, 0.4 over the control is already giving you an indication that enzymes are doing the job of reducing the oil. Obviously, when we use enzymes, we expect a higher increase, like in this case. In this case, we in a trial 1 without enzymes and a trial 2 with enzymes. This is a trial done in Chile in 2018. We were able to improve or recover 1.3% oil, or 13 kilos more of oil per 1,000 kilos of fruit. And that obviously gave me the indication that enzymes were certainly working on this kind of paste. Also, this work done by the Fat Institute in Seville on picual fruit of very low maturity, 1.1 maturity. They also measure yields of a control with no enzymes. This is done this is a test done in Avencore, so I mean bench equipment, laboratory equipment. A control against 2 different enzymes, enzyme 1 and enzyme 2. And obviously in this case, both enzymes gave a clear increase of yields as compared to the control. We also look at measuring or understanding what the energy consumption of equipment, and particularly in the case of the malaxer torque, that's a very easy parameter to measure, simply because in most cases, when you're working in the mill, you have that parameter displayed in the panel in the control panel of equipment. So in this case, we work with a control without enzymes, an enzyme A and an enzyme B, and we measure the malaxer torque. In this case, in fact, we didn't measure it. It was already being displayed. It was being measured by the equipment. And we found that, as we were expecting, as we add enzymes into the process, because enzymes make the paste more fluid, then it is easier for the motor of the malaxer to move those blades inside the malaxer. And there's a lower energy consumption as a consequence of that. So there was a drop from 4.7 ampere to 4.5 ampere in the case of enzyme A, and 4.3 ampere in the case of enzyme B. So this is another parameter that obviously is of interest to us. And of course, we also had to look at the efficiencies obtained in the process, because obviously we are adding enzymes just for the sake of getting more oil out of the paste. In this case, both enzymes perform much better than the control without enzymes. This was a test done in Argentina a few years back. Also, if you look into the pressure of the paste pump in the processing plant, and again the ampere consumption of the equipment, is a work that I did in using variety Lecino in China in 2017. 3 different dosages of enzymes against a control with no enzymes, measuring the ampere consumption of the malaxer that dropped clearly, and also the pressure of the paste pump in bars that dropped from 1.7 bar to 1.4, 1.3, 1.2 as I increased the enzyme dosage. And obviously, again, measuring industrial efficiency in each case that increased as the enzyme dosage was increased in this particular case. This is another work done in Chile in 2018, working with fruit of very, very low maturity. As you can see here, this is Arbequina, an iconic variety of that country. working with a fruit, a paste with no enzymes, a control with no enzymes, with a mix of enzymes and then a single enzyme used. And as you can see here, the malaxation, the malaxer consumption, the torque, without the enzymes added into the process. I mean, in the case of the control, the motor was using pretty much 100% of the torque that the motor could stand. In this case, I was getting only 70% industrial efficiency, or a yield of 9.1%. And then as we started using enzymes, in the case of the second enzyme, which was a strong mix to use in this kind of fruit, very green, viscous paste, that was able to drop the malaxer consumption, the torque, by almost 50%, and increasing significantly the industrial efficiency of the process. The other parameter that we look at is the paste pump speed. We know that as we add enzymes into the process, the paste becomes more fluid, and then it's easier also for the paste pump to pump that paste into the decanter. So this was a work done in California many years ago with 3 different products working against a control, where I also measure industrial efficiency, but I also measure the paste pump pressure and also the paste pump speed. As you can see, the loss in pressure was clear from no enzymes added to enzymes present in the paste, but also at the same time and at the same setting of the paste pump in hertz, the speed of the paste pump was increasing as the paste became more fluid. In the case of viscous ML, which is a strong enzyme that works really well in Arbequina, this pretty much gave an increase of 100 kilos an hour more than the control working at the same setting of the paste pump. In another test done in Chile in 2018, working at 7,700 kilos an hour, using enzymes, we only had to set the paste pump at 23 hertz to be able to pump those 7,700 kilos an hour, while without enzymes, with the paste more viscous, we had to increase the tension of that paste pump in order to match the same paste pump speed. Oil cleanliness is also another parameter that is important to assess in the case of enzymes. This is a work done in a few years ago by Najafian and his team of researchers in 2009 with Koroneki, oleaginous, and Mission, using 2 different enzyme dosages. And what these researchers did, they basically studied the color of the oil coming out from the decanter in each case, and the turbidity of the oil, which is measured by the NTU unit, which is the nephelometric turbidity unit, which simply measures the cloudiness of the oil, or how clean the oil is in this case. What he found was clearly that in each variety, in all varieties, as he increased enzyme dosage into the process, he was able to get an oil with a lower NTU index, meaning that the oil was coming cleaner from the decanter. But why the oil comes out cleaner from the decanter is very simply because when we look at the speed of sedimentation in centrifugation of a paste, we'll see that as we add enzymes into the process, enzymes separate clearly the oil from the paste, then the differential in density between the density of the paste and the density of the oil becomes bigger, and as a consequence, because there's a bigger gap, there's a faster sedimentation speed inside the decanter, and as a consequence, the oil comes out cleaner. So that's another parameter, very important parameter that you'll probably notice when you use enzymes. The oil definitely comes out cleaner. Happens the same when you use talcum powder. Paste viscosity is another parameter that you will see that will have an evolution as we use enzymes in the process. But typically, as you add increasing enzyme dosages in the paste, you will see that the viscosity of the paste, that is measured in centipoise, and is represented here by the columns in blue color. As you increase the enzyme dosage addition into the paste, that viscosity will drop until there are no more drops in viscosity, meaning that you have already reached the threshold for that parameter in the paste. And you will also see there is a correlation with a strong correlation with industrial efficiency of the process. So as you reduce viscosity, typically there is an increase in the industrial efficiency of the process until you reach a plateau where there's no more gain from the increase of the enzyme dosage. So the paste viscosity has been reduced to a certain level where you have that parameter loses correlation with the industrial efficiency, and after that point you realize that there's no more point in increasing dosage of enzymes for oil extraction. Some experiences from years of working in this. When you work in the case of arbequina, typically from arbequinas coming from super high density groves, where you tend to have fruit of low caliber, small size. When you encounter 3 out of these 4 parameters, basically you know that you will have a problems with paste viscosity. So when you deal with arbequina fruit that has lower than 1.3, 1.4 grams of average fruit weight, you have fruit that has lower than 50% moisture, or fruit that has a lower content, say less than 14.5%, or fruit that is really green or low maturity or lower than 1.4. When at least 3 of these 4 parameters are combined, and you're dealing with fruit that shows these 3 or 4 parameters, you know that you will have a problem of viscosity in the process, and as a consequence of that, you know that you have to reduce viscosity in order to get the oil out. So when you encounter a problem like this, you have 2 options. You either increase the enzyme dosage in the process, or if you do not use enzymes, you are forced to add a bit of water into the process at the malaxer or the decanter in order to reduce the viscosity of that paste, which is the other way of reducing viscosity in paste. The big difference in these 2 tools is that enzymes don't have an impact on oil quality, while water added to the malaxer clearly has an impact on the polar compounds of the oil, typically polyphenols. So you're washing away polyphenols from the paste. When we're working in the mill, obviously, as oil processors, we are continuously checking the condition of the paste in the malaxer, because that gives us a very strong indication whether the paste is ready for centrifugation. What happens when we use enzymes in the process, as we add enzymes in the process, typically the paste, which is already still fresh, has a coarse particle size, a high viscosity that's typically seen paste like this. But 15 minutes after that, as you know, after adding the enzymes, you'll see that the paste has changed its look and has now a very finer particle size, and there's a strong drop in viscosity. So as soon as you put enzymes in the process, you will see that very quickly there's a strong drop in that viscosity of the paste. Then 60 minutes after that, after adding those enzymes, you see that clearly there is a lot of oil released, overflowing the paste. There's a higher paste fluidity. There's a bright, shiny aspect of the paste that is typically given by the presence of droplets of oil coming up to the top of the malaxer. There's now a lesser drop in viscosity. So basically, when you add enzymes into the process, the very strong drop in viscosity happens in the first 15 minutes. After that, there's only a very small drop in viscosity until you get to the slow 60 minutes of malaxation. The pomace condition is another aspect that we look at. Obviously, we measure oil losses in the pomace. When you use enzymes, you notice a clear drop in oil losses in pomace, as opposed to a paste that has no enzymes addition. In this case, Sharma, another researcher in 2007, used different enzymes, increasing dosages to understand what the moisture content of the pomace was, because enzymes extract a lot of liquids from the paste, and as a consequence of that, the pomace comes out typically drier. So when this researcher did this test using increasing amount of enzymes, he found that in all those enzymes tested, the higher the dosage, the lower the moisture content of the pomace obtained in the process. If you use enzymes, you see, as you can see in these photos, that when you use enzymes, the pomace comes out with a more consistent look, as opposed to the typical pomace that comes out from the process with less consistency when you don't use enzymes in the process. So remember, these enzymes certainly have an impact on the pomace condition that you're getting. Sustainability is another aspect that is important to measure in this case, as you are exhausting much better the pomace in the process. I mean, you're releasing or letting go pomace with lower oil content. That pomace is more environmentally friendly because you're reducing the consumption of energy of the processing equipment. There's a lower energy consumption in the whole process, and as a consequence of that, there's also a minor environmental footprint by the use of these tools in the process. Obviously, if you're using enzymes or any other processing aid, you certainly need to understand whether there is an impact on oil quality. We have to remember, and this is extremely important, processing aids must not have an impact on oil quality for good or for bad, obviously. So when we use enzymes or any other processing aid, we have to ensure that we test quality to make sure that this principle is met. These are works done by different researchers studying the basic chemical parameters like free fatty acids, peroxide value, K232, K270, which are oxidation parameters that measure secondary oxidation in olive oil, shelf life, which is measured by an equipment called Rancimat in different varieties. Also, either studies on either minor components of the oil, like sterols, which are, as I said, minor components in the composition of olive oil. But there is a wide range of studies that demonstrate that enzymes do not have an impact on quality, on the chemical quality, or on the sensorial quality. So this is extremely important to remember, because if they had an impact on a negative impact on quality, they would not be able to be used for olive oil making. So how do we determine the most cost-effective enzyme dosage that we apply in the process? We say that enzymes are expensive. They're also extremely cost-effective, but using the appropriate enzyme dosage is key to make the process economical. So when we do dosage trials, we can certainly do this at laboratory level if we have an Avancore equipment, as you can see here in these photos, or we should be able to do trials at processing plant level, which are also a good indication whether or not enzymes are working. When we do trials with Avancore equipment, typically in the space of only 1.5 hours, 2 hours, we already have results on this equipment. This equipment simply replicates the process that happens in the real world by having a small crusher, a small malaxer, and a small centrifuge that drops all the liquids obtained in each test in volumetric cylinders. Then what we do is we just measure the oil obtained, total oil, clean oil obtained in each of those parameters. We also measure the liquid interface in each of those tests to then work out what the yields were in each test. So if we do enzyme dosage trials, you get to see something like this: a control with no enzymes, 300 mils, 600, 900, 1,200, 1,500, and so forth. And then you get to see that there's clearly an evolution like this, where you have an increase of of oil released, total liquids release, and oil release, until you get to a point where you don't get any more release by increasing the enzyme dosage. You know that at this stage, your enzyme dosage is the most appropriate for the kind of paste you're dealing with. And so how we apply those enzymes to the process once we have determined what the best enzyme dosage is. We certainly use pulsating pumps like the one you get to see in this picture. These enzyme dosing machines are used in large processing plants working in continuous mode. They simply have a display where you adjust the liters per hour that are adjusted based on the paste pump speed of the decanter. But if you work in manual mode, because you're a small processor and you don't work in continuous mode, then it is better to add the total amount of enzymes that you need at the beginning of the malaxation time, so as to increase the contact time between paste and enzymes. So if you're not working in continuous mode, you know that you have a malaxer with 10,000 kilos of paste. You know that you had to add 2 liters of enzymes in those 10,000 kilos. Then you add those 2 liters right away as you start filling the malaxer, because you need time for the enzymes to do the job. Where we add enzymes, we add those enzymes immediately after the crusher if we are using a pump like the one you're seeing here, or at the top bar of the malaxer if we are working manually. Obviously, the most important message here is try to put the enzymes as soon as the paste comes out fresh from the crusher, because increasing contact time is very, very important in this process. The other aspect that you have to consider is that enzymes are advisable to be added diluted in water, because water is a vehicle for the enzymes to reach every single corner of the malaxer. So dilutions of 4:1 to 5:1 water to enzymes are recommended when we are using these products. Do we have to do any adjustments in the decanter when we use enzymes? Well, certainly, if we are using enzymes, we're increasing the release of oil. If we increase the release of oil, when we put the paste inside the decanter, you'll get to see that the oil ring inside the decanter, which is always against the axle of the decanter, which is always within the water ring and within the pomace ring. So that oil ring, when we use enzymes, will become thicker because there will be more oil released. And if that ring becomes thicker, then it means that you had to increase the oil plates, the exit plates of the decanter, in order to evacuate that oil properly from inside the decanter, because the decanter should not be working with too much oil inside. So again, using enzymes increases the amount of oil that is released, increases the size of the oil ring inside the decanter, and as a consequence of that, that forces you to increase the outlets of the decanter. So it's advisable to go to a larger plate number inside the decanter. It is always a good idea to inject also a little bit of water into the decanter, up to 3-4% water if working in two phases inside the decanter, so as to contain the size of that oil ring, because the water ring will put pressure on that oil ring. So adding a little bit of water will force the oil to evacuate properly from inside the decanter. Always remember, as I mentioned before, if you're using enzymes, the pomace will come out a bit drier, and for this reason you should be able to check and clean the pomace exit of the decanter in a regular basis, just to make sure that there's no dry paste that gets stuck in the pomace exit that could have an issue on the decanter. And also remember, as you add enzymes into the process, the paste becomes more fluid, and as a consequence, you should adjust down a little bit the paste pump speed in order to work at the same speed that you want to work, or you were working before adding enzymes, because you know that at the same setting of hertz, adding enzymes in the malaxer will increase fluidity, and that paste pump will pump more paste on a per hour basis into the decanter. Now, just to finish it off, obviously we have to talk a little bit about the legislation on enzymes, because obviously, as we know, enzymes are not allowed for use in Europe. The European Community legislation of July 2001 clearly says that in order to preserve the natural characteristics of virgin olive oil, the use of oil extraction adjuvants that have a chemical or biochemical action should be excluded. And when they use the word biochemical, obviously that put enzymes out of question. I obviously disagree with the concept of preserve the natural characteristic of virgin olive oil. I mean, enzymes have no impact whatsoever on the natural characteristics of virgin olive oil, and that has already been proven. The International Oil Council and the Codex definition of olive oil don't mention anything about the use of enzymes, so this is very interesting. It's only the European Community, the one that doesn't allow the use of enzyme. In Europe, the IOC, or the International Olive Oil Council or Codex, don't say anything about the use of enzymes in the oil extraction process. In the case of Australia, the Australian standard was developed in 2009 and then approved in 2011. Has the same definition of olive oil as the case of the Codex or the IOC definition, but in the Article 9.3, this standard clearly says that processed aids are allowed to be used during the oil extraction process to the extent allowed by the Australia and New Zealand Food Standard Code. And when you go to the ANZ code, in the section 1.33 for processed aids, it clearly says that talc powder and pectinase enzymes can be used for olive oil making. And this was obviously done after extensive research done on enzymes to ensure that first, they do increase oil release, and second, they do not impact on oil quality. In California, the Olive Center, which is the Olive Institute that is related to the University of California in Davis, clearly promotes the use of enzymes and talc for olive oil making in that country. And the case of Argentina is an emblematic case because enzymes were approved recently in February 2021. They were approved by the local food code, and the way the work was done was, technical evidence from research that was done in the country and overseas was used to support the claim before the local food authorities. And obviously, the cases of Australia and USA were used as reference points for this approval. And the formal request for enzymes was pushed by local producers. This is the important message here. It was the actual olive oil makers that saw the benefit of using enzymes in the process that basically pushed for authorities to get the enzymes approved. All this was a work that requires a bit of administration, obviously. This was done by the Olive Chamber of the San Juan province, one of the most important provinces for olive oil making in that country. And then producers got the work done, and enzymes were approved in this country. Anyway, so this is pretty much what the experience I wanted to share with you. I appreciate your presence today in this presentation, and I leave it to Paulo to discuss if there are any questions on this.